Hello everybody, welcome back. These are examples of the convergence tests that we have, and I thought we'd do the homework. So for this video, it's the homework. The first four, I use the integral test, number 1 through 4. And there's something that needs to be said, 1 through 4. There's something that needs to be said. We're going to take a infinite series, and we're going to use a function to emulate that series. And this function must be f of x, must be continuous, positive, and non-increasing. And they all are. Number 1 through 4 are. Just thought we should mention this, because you have to check that out first. For example, number 1, we're going to create this function, f of x is 1 over x plus 3. And what we want to do is integrate that from 1 to infinity. But first you have to be, it's positive no matter what x is, it's continuous, it's an irrational function, and it's non-increasing. So we want to integrate this, 1 over x plus 3 dx, and you get ln x plus 3 from 1 to infinity. That diverges. It does not have a limit. Diverges. For that matter, same with 3 and 4. Let's do number 2 over here, and 3 and 4 will not happen in no time. Number 2 is a convergent one, and why we start here from 100, I don't know. It wouldn't matter, just to make a point, I guess. 3 over x plus 2 squared, and that's what we're going to integrate, because that's the series that we're trying to... and so we integrate that, and you get, what is it, negative 3 over x plus 2 to the first. And we're going from 100 to infinity there. Notice when you from infinity, notice you put the infinity in that 0 and plus, right? Plus 3 over 102. Well, that's good. That series converges. If this limit exists, this series converges. 3, exactly like number 1. Ln 7/4 ln 4x plus 2 converges. Diverges because of the infinite right there. And same with number 4. Integrate 2x over x squared plus 5. You use a u substitution. Anytime you use a u substitution, and you're going to get a logarithm, diverges. When I say diverges, I mean the series that we're using to represent this. This limit goes off to infinity, so therefore the series diverges. That's number 1 through 4. That's the integral test. The first of our tests of divergence. Let's get to number 5. I think number 5 is the comparison test. Oh, and 6. And so we're going to come up with a function, a series to compare this with. So we want to test the convergence of this, n over 5n squared minus 4. We want to test the convergence of that. And so I'm thinking, what happens as n gets big? Well, this is like n over 5n squared as n gets big. And please note, this is what you have to do with comparison tests. N over 5n squared minus 4, because that gets lesser. N over 5n squared. Gets lesser. This is greater than. Right, I even wrote that down. Please note that. And what we're going to show that this diverges, so then that one must as well. And so n over 5 is equal to 1/5 times the harmonic sequence. If this one diverges, that one must as well. Do I have this backwards? Come on. Put a 3 in there. 3 over 9, 41. 3 over 75. Yeah, 45. This one is greater. Yeah, so I had that right. So if that one diverges, and I'm so sorry. 1/5, the series 1/5 times 1 over n diverges. Since it's harmonic. It's 1/5 the harmonic series. The harmonic series diverges, so then this one will also diverge. 5n squared minus 4 diverges. I'm sorry about this middle stuff. I had it done, but it's on the spot. That's the important part of the comparison series. Comparison test. How about number 5? I hope I can get the right one. Number 6. Number 6 is over here. The series n equals 1 of n over 2 to the n times n plus 1. Yeah, this is the one I absolutely did. Okay, now please note, this I'm sure of, n over 2 to the n times n plus 1 is strictly less than 1 over 2n. This, this will always be a fraction. 3/4, so that's strictly less than. Once we have that, we know, because this sequence converges. Since 1 over 2 to the n converges, so does n over 2 to the n times n plus 1. If the greater one converges, certainly the lesser one converges as well. Anything else? Oh, by the way, this sequence, this series is 1 plus a half plus a fourth plus an eighth. We talked about that one. It's 1 over 2 to the n. The limit of this is 2. Okay. 6, 7. 7 and 8. Oh, yes, 7 and 8. We're going to come back to more examples of this. Limit comparison and ratio, but let's finish these two. And we want to do 7. Looks like, oh boy, I'm all messed up. Yeah, I had 6 and 7 backwards. It looks like this one, n squared over n squared over n squared plus 2n plus 3. We want to test the convergence of that. And so what we're going to do is we want to think about what this is like when it gets big. As n gets big and increases, this acts like 1 over n. And we know stuff about that. So what I'm going to do is take this and divide it by 1 over n, and we'll find out what we get here. And so this is n over 1. Of course, we're multiplying n squared. So this whole thing, n squared. I have it. Over n squared plus 2n plus 3. And I did that, and now this is what I want to take the limit of. Limit of n squared over n squared plus 2n plus 3 is 1. And since 1 is in between that and infinity, this converges. That's number 7. And number 8 is a ratio test. Knock that baby out, and then 8. There, 8. Investigate 8 to the n over n factorial. By the way, the ratio test I think is the most powerful, strongest. It's also coming back to us. So what we want to do is the nth term of this sequence, the n plus first one will be this, and we're going to divide that to the nth by the nth term. And find out where that limit is. And so we'll flip this baby, n plus 1 over 8 to the n. Let's see, this is, that's 8. This is over n plus 1. And because the limit, as n goes to infinity, of 8 over n plus 1 is 0, which is less than 1, this series converges. Okay, that's the homework. I'm going to do some more examples in the next video. See you soon.